Morning students, I am going to present the video lecture on artificial intelligence. I am Anita, belong to Department of Artificial Intelligence and Data Science from Veritech Multitech, Dr. Rangarajan, Dr. Sakatala Engineering College. So this course is going to present for the second year, third semester students. Today, I am going to discuss about the topic knowledge-based agent. Before start the topic, we should remember what is an agent and knowledge. First, we are going to see agent. Agent is nothing but is anything that can perceive its environment through sensor and act upon that environment through effectors. Next, knowledge. Knowledge is nothing but any fact, information, and skills acquired through experience or education. Now we are going to see intelligent agent. An intelligent agent needs knowledge about the real world for taking decision and reasoning to act efficiently. Now we are going to see knowledge-based agent. Knowledge-based agent are those agents who have the capability of maintaining an internal state of knowledge, reason over that knowledge, update their knowledge after observation, and take action. These agents can represent the world with some formal representation. Now we are going to see parts of knowledge-based agents. Knowledge-based agents are composed of two main parts. First one, knowledge-based, and the second one, inference system. The knowledge-based agent must be able to do the following. First point, the agent should be able to represent the state and action. An agent should be able to incorporate new concept. An agent can update the internal representation of the world. An agent can reduce the internal representation of the world. And the agent can reduce appropriate actions. Now we are going to discuss about the architecture of knowledge-based agents. The above diagram is representing a generalized architecture for a knowledge-based agent. The knowledge-based agent take input from the environment by perceiving the environment. The input is taken by the inference engine of the agent and which also communicate with knowledge base to decide as per the knowledge stored in knowledge base. The learning element of knowledge base agent regularly update the knowledge base by learning new knowledge. Next, first component, we call it as knowledge base. Knowledge base is a central component of a knowledge base agent. It is also known as knowledge base. It is a collection of sentence. Here, sentence is a technical term and it is not the identical to sentence in English. These sentences are expressed in a language which is called a knowledge representation language. The knowledge base of knowledge base agent store facts about the world. We use a knowledge base. Knowledge base is required for updating a knowledge for an agent to learn with the experience and take action as per the knowledge. Next, we are going to see inference system. Inference means deriving a new sentences from old. Inference system allows us to add a new sentence to the knowledge base. A sentence is a proposition about the world. Inference system applies logical rules to the knowledge base to deduce new information. Inference system generate new facts so that an agent can update the knowledge base. An inference system works mainly in two rules. First rule, forward chaining, and second rule, backward chaining. And knowledge-based agents perform some operations. So what are the operations? Here we mentioned three operations. First operation, tell operation. This operation tell the knowledge base what it perceived from the environment. And the second one, ask operation. This operation asks the knowledge base what action it should perform. And third one, perform operation. It perform the selected actions. So the three operations which are performed by knowledge-based agent in order to show the intelligent behavior. Now we are going to see generic knowledge-based agent. So this is the structure of generic knowledge-based agent. So in the structure, so that we return one knowledge-based agent functions. So in the functions, knowledge-based agent takes percept as input and return an action as output. The agent maintains a knowledge base, KB, and it initially has some background knowledge of the real world. It also has a counter to indicate the time for the whole process, and this counter is initialized with 0. Each time when the function is called, it performs three operations. First, it tells the knowledge base what it perceives. Secondly, it asks knowledge base what action it should take. Third, agent program tells the knowledge base that which action was chosen. And inside the tell operations, we return make for sub sentence. So the sentence denote generate a sentence as setting that the agent pursued the given person at the given time. And the second one, make action query. It indicate it generate a sentence to ask which action should be done at the current time. And the third sentence, make action sentence. It denote the generate a sentence which assert that the chosen action was executed and increment the timer value and return the action. Now we are going to see various level of knowledge based agent. Knowledge based agent can be viewed at different level. First level, knowledge level. Knowledge level is the first level of knowledge based agent. In this level, we need to specify what the agent knows and what the agent goals are. With this specification, we can fix its behavior. For example, suppose an automated taxi agent needs to go from station A to station B, and he knows the way from A to B. So this comes at knowledge level. Logic, second one, logical level. At this level, we understand that how the knowledge representation of knowledge is shown. At this level, sentences are encoded into different logic. At the logical level, an encoding of knowledge into logical sentence occurs. At the logical level, we can expect to the automated taxi agent to reach to the destination P. And third level is implementation level. This is the physical representation of logic and knowledge. At the implementation level, the agent performs action as per logical and knowledge level. At this level, the automated taxi agent actually implements his knowledge and logic so that he can reach to the destination. Next, we are going to see approaches to designing a knowledge-based agent. Here, mainly two approaches to build a knowledge-based agent. First one, declarative approach. We can create a knowledge-based agent by initializing with an empty knowledge base and telling the agent all the sentences with which we want to start with. The approach is called declarative approach. And the second one, procedural approach. In the procedural approach, we directly encode the desired behavior as a program code, which means we just need to write program that already encode the desired behavior or age. Now we are going to see propositional logic. Propositional logic is one of the knowledge representation technique. Propositional logic is the simplest form of logic where all the statements are made by proposition. A proposition is a declarative statement which is either true or false. It is a technique of knowledge representation in logical and mathematical form. Let's see, let's see some different examples. So first example, Sunday is holiday. So is it true statement? It is called it as true proposition. The second example, sun rises from east. Is it this is false statement? So we call it as false proposition. And the third example, 3 plus 3 equal to 7. So this is false statement. We call it as false proposition. And the fourth one, 5 is a prime number. This is a true statement. So we call it as true proposition. Now we are going to see some basic facts about the propositional logic. Propositional logic is also called Boolean logic. It works on 0 and 1. In propositional logic, we use symbolic variable to represent the logic, and we can use any symbol for a representing proposition, such as A, B, C, P, Q, or etc. Proposition can be either true or false, but it cannot be both. Propositional logic consists of object, relation, function, and logical connectives. These connectives are also called logical operators. The proposition and connectives are the basic element of propositional logic. Connectives can be said as logical operator which connect two sentences. A proposition formula which is always true is called tautology, and it is also called valid sentence. A proposition formula which is always false is called contradiction. The statement which are questions, comments, or opinion are not proposition. See an example. Where is Rogini? How are you? What is your name? These are the statement or not proposition. Now we are going to see syntax of propositional logic. The syntax of propositional logic defines the allowable sentence for the knowledge representation. Here we see two type of proposition. First one, atomic proposition, and second one, compound proposition. First, atomic proposition is nothing but simpler proposition. It consists of single proposition simple, and these are the sentence which must be either true or false. Let's see one example. 2 plus 2 is 4. So this is an atomic proposition. The statement represent it is a true fact. And second one, sun is 4. It is also proposition, but if the statement tell that it is a false fact. And the second one, compound proposition. Compound proposition are constructed by combining simpler or atomic proposition using parentheses and logical connectives. So let's see one example. It is a raining today. Street is west. So in the first statement represent uh, the first statement having two type of sentence. First one, it is raining, and second one, street is west. So the two statement combine with logical connectives and. So we call it as compound proposition. And the second example, Angit is a doctor and his clinic is in Mumbai. So in the statement represent two type of statement. First statement, Ankit is a doctor, and the second statement is screening is in Mumbai. So the two type of statements combined with logical connective and operators. So these statement call it as compound proposition. Next, we are going to see logical connectives. Logical connectives are used to connect two simpler propositions representing a sentence logically. We can create compound proposition with the help of logical connectives. We have used five types of logical connectives in knowledge representation. And the first connectives negation. First, we take any sentence. So before the sentence, we put negation simple means that statement is called negation statement. See an example. Before we represent one symbol. That symbol is called negation. The literal can be either positive literal or negative literal. And the second one, conjunction. A sentence which have conjunction connective such as P conjunction Q is called conjunction. Let's see one example. Rogan is intelligence and hardworking. So in this statement, we mention and logical connectives. We call it as conjunction statement. So in the statement, we represent in variable. So first statement, we assign to P variable. Rogan is intelligent. And the second statement, we assign to Q variable. Rogan is hardworking. So how will you write the conjunction statement? So P and Q. So this is the conjunction statement. And the third one, disjunction. So in the statement which have V connectives, so we represented it P, V, Q is called disjunction, where P and Q are proposition. Let's see one example. Ritika is a doctor or engineer. So in this statement, we mentioned that R. So R logical connectives used in this statement. So in the statement, we divide the statement and assign the two variable. First one, P variable assigned to Ritika is a doctor and Ritika is a engineer is assigned to Q variables. Now we are going to write the disjunction statement. So how will we write means P disjunction Q. So write that we have to create the we have to create the statement using logical connectives. Now we are going to see implications logical connectives. A sentence such as P implies Q is called implications. The arrow symbol represents the implication logical connectives. Implications are also known as if controls. Let's see one example. If it is raining, then the street is west. So in this statement, we see that it is a conditional based statement. We call it as implication statement. So in this statement, we know that two statements are there. The first statement assigned to P and the second statement assigned to Q. It is raining, we assign to P variable. Street is west assigned to Q variable. So how to write the implication statement means it can be represented as P implies Q, so we have to use arrow symbols for implications. And the second and last logical connectives biconditional. A sentence such as P biconditional Q is a biconditional statement. So these symbols represent the biconditional. This is both arrow symbols. Let's see one example. If I am breathing, then I am alive. So in the statement also, then if and only if condition based statement, we call it as right conditional statement. So in the statement, here also we used two variable and assign the variable, assign the statement to the particular variables. So I am breathing, we have to assign the P variable. I am alive, we have to assign the Q variable. So we have to represent it in the statement P by conditional Q. So this is represented by conditional statement, and we are going to see truth table for proportional logical connectives. Here we see the table. It represents connective symbols and words and technical terms and examples. So, what are the connective symbols are used in knowledge representation, and which is related? What are the words we have to represent it? And what are the technical terms we are used in? And we have seen the example. First, simple and simple. So we represent the simple like this, and we use the technical term conjunction and see one example A and B. And the second one we call it as R simple. So this is B simple. So we use the word R and the technical term dissension and A or B. And the third one implications. So we use the word implies and technical term we used implications. So I will write this A implies B. And the fourth one we used the word if and only if. This simply is called biconditional, and we see the example. I will write it A biconditional B. And the last one we say negation symbols. So we use the word not and we use the technical term negation, and we see the example. How will they write it? Negation of P or negation of P. Now we are going to see truth tables. Truth table means words. We take the input variable. After filling the logical connectives, we got the output variables. So we have seen five types of logical connectives. First one, negations. So in the negation, we take the statement and assign the variable to P. So that statement is true means after applying the negation symbol of P, that statement is false. So when you take the false statement, after applying the negation symbol, that statement is true. And the second one, conjunction. Conjunction will take two statement. First statement is true and assign the P variable, and the second statement is true and assign in the Q variable. After applying the conjunction symbols, we get the two statement. That is P and conjunction Q. And the second one, so when the statement P is true, when the and the statement Q is false, that's after applying the conjunction, that statement is false. And the third one, when the statement P statement is false and the Q statement is true, after applying the conjunction, the statement is false. When the P statement is false and the Q statement is false, after applying the conjunction, the statement is false. The next one is junction. So this junction also take two statement. So we take the two variable P and Q. So if the statement P statement is true and the Q statement is true, after applying that extension, the statement is true. And the second one, when the P statement is false and the Q statement is true, After applying the disjunction, the statement will be true. The third one, the P statement is true and the Q statement is false. After applying the disjunction, the statement will be true. And the fourth statement, P statement is false and the Q statement is false. After applying the disjunction connectives, the statement will be false. And the fourth one, implications. The implications also take two statements, P and Q. So if the P statement is true and the Q statement is true, after applying the implications connectives, the statement will be true. And the second one, P statement is true and the Q statement is false. After applying the implication connectives, the statement will be false. The first is third one, and the first statement P is false, and the second statement Q is true. After applying the implications, the statement will be true. And the last one, the P statement is false, and the Q statement is also false. After applying the implications, the statement will be true. The last logical connectives is biconditionals. So in this logical connectives, we take two statements P and Q. If the P statement is true and the Q statement is true, when we apply the biconditional logical connective, the statement will be true. When the P statement is true and the Q statement is false, after applying the biconditional connectives, the statement will be false. When the P statement is false and the Q statement is true, after applying the biconditional connective, the statement will be false. When the P statement is false and the Q statement is false, after applying the biconditional connective, the statement will be true. So these are the logical connectives used in knowledge representations. Next, we are going to see the limitations of propositional logic. So here we cannot represent the relations like all, some, and none with propositional logic. Let's see one example. All the girls are intelligent and some office are sweet. So in this statement, all and some we cannot use in the propositional logic.